Alright, so this video is going to be about how to create a force diagram from a video for your project. So if I have this video of a kid running, sliding to a stop, and I want to create a quantitative force diagram of what's happening, I can do so. Okay, and so this video is going to be all about how to do that. So probably step one when creating a force diagram of something like this, it's going to be to make a qualitative force diagram. So we're going to be doing this from video, so I guess first and foremost I just want to start off and recognize what forces are present when the kid's sliding on the ice. So right now, obviously he's standing there, he's an object, has mass, so there's going to be a force of gravity there that's present. Likewise, since he is on the surface, okay, he is also receiving a normal force. So now, without even having to calculate numbers, I can find what those two would be, or I know that they're equal, opposite, and balanced. And so from that then, we have one more force present. So the kid's sliding to the left. Now there is not an applied force to the left, that's just his inertia carrying him, but what's slowing him down is friction acting to the right. So if I'm to create a force diagram, I also have a force of friction here. Okay, and so if I wanted to create a quantitative force diagram from this, I'm going to need a couple other things, like, for example, a mass, so I can solve for a force of gravity, and then we're going to need to use video analysis to come up with other things that we can use to help us. So here's how to do that. You're going to insert the same movie into Logger Pro, and so what we would then do is actually do video analysis of this object sliding.
So that means normal video analysis procedure applies. First off, set our scale. So when we do that, get a known distance. Now I have a nice long distance in mind, so I'm going to use that. I know that that distance right there, instead of our default of 1 meter, it's actually 10 meters. So I'm going to tell it 10 meters. We have to set our origin, and so since I have this nice little, oh, wrong thing there. That was adding a point. To set my origin, using the origin tool, I'm going to put it down by his feet. I'm going to start it at the 0 meter mark, and so that's going to mark where we actually start doing our video analysis. Now, when we're doing this then, we got to play the video and get it to where we're actually in a spot where he's in the frame now. And so, as he moves into the frame, I got to find exactly where I want to start. And it looks like I'm going to make this be the start. And so we're going to use his shoulder as our point for video analysis. So click to add the point. I'm going to frame ahead a couple. That way we have a more clear path of what's happening. So through the magic of video editing, I've completed adding my points, which means I now have the capability to look at graphs. So your default is a position graph. Again, this one doesn't give me a ton because I know if I'm looking at forces, I need an acceleration. So in order to get an acceleration in this case, I got to go to my velocity graph. Now, I use x because this object's moving completely and totally in the x direction. And so if I look at this and I put a line in, what that gets me is a slope, which tells me the acceleration of this object. So it looks like my object's accelerating at 0.4799 meters per second squared. We're going to call that 0.48 meters per second squared. So I now know an acceleration of 0.48 meters per second squared. That also then means that I can find my acceleration and my unbalanced force. So in this case, I have an acceleration. I'm also then looking to find an unbalanced force, because also in this case, look, I have these two balanced. There's nothing acting against this, so that means my unbalanced force is the force of friction. The only thing that I would need to do that is a mass. So again, going back to our video, if I'm actually going to come up with an unbalanced force, I need to know the mass of the person in the video. So for the simplicity of the sake, we're going to say it's 100 kilograms. So that means my mass, if it's 100 kilograms, again, if I shot the video, I would know the exact mass because I'd be able to weigh the guy. But that said, mass is 100 kilograms, which means then I can figure out my FU, I can figure out my force of friction, I can figure out the rest of these. Here's how. So unbalanced force, FU, is equal to MA. And if we're looking for our unbalanced force, it's going to be 100 times our acceleration, 0.48, which means my unbalanced force here is going to be 48 newtons. So my force of friction is 48 newtons. Okay? And then these two are equal and opposite. And I know if my mass is 100, mass times gravity, this ends up being 980 newtons, and as is this one. Okay, now the last thing that we can do, and since this is kind of like your project, we can find out more information, like say the coefficient of friction of his feet on the ice. We should do that because we know the force of friction is equal to mu times force normal. So as a bonus, we can solve for force of friction. I'm sorry, coefficient of friction. So 48 is our force of friction. Mu we're interested in getting, and the normal force is 980. So again, just using algebra to solve for that, our coefficient of friction then becomes 48 divided by 980. So 0.05 is our coefficient of friction. Okay, so this is an example of how you can build a force diagram based off of video using Logger Pro and using what we know we can measure in real life.